An important aspect of chemistry is naming compounds. We have molecular formulas which tell us the types of elements and the number of each, but we want to be able to name compounds in words to better communicate what's happening. Now, how we name compounds depends on whether we're talking about ionic or covalent compounds. For ionic compounds, remember we have a cation and an anion. These come together to produce a neutral compound. What this means is that any cation and anion combination will only produce one compound. For instance, if I have Na plus and Cl minus, they're only going to form NaCl. They won't form NaCl2 or Na2Cl. They only produce NaCl because it's the only molecular formula that gives you a neutral compound. How we name ionic compounds follows 3 steps. The first thing we do is we name the cation. In this case, that would be the sodium. If the cation has a variable charge, we have to add that charge in brackets. This is most common when we're talking about transition metals. Then finally, we name the anion. Now, naming the anion has 2 different types. One is if the anion is a monatomic anion. That means it's by itself. So for instance, if you have carbon as your anion, we change that carbon to carbide. Nitrogen gets changed to nitride, phosphorus to phosphide, sulfur to sulfide, fluorine to fluoride, chlorine to chloride, bromine to bromide, and iodine to iodide. One key one is oxygen. Oxygen gets changed to oxide. This is really important because we end up seeing a lot of oxides on Earth, and that's because Earth's atmosphere has oxygen on it, O2, and so we see a lot of oxides. Now, if the anion is a polyatomic anion, such as SO4 2-, in that case, we do not change the ending. So SO4 2- is sulfate, so in a name, we leave it as sulfate. We don't change it to sulfide. Let's look at some examples. So let's say we have MgCl2. We can look at the periodic table, and we can see here's my magnesium, here's my chlorine. My magnesium is the cation. So we go ahead and we name the cation. We do not have to include a charge. That's because magnesium is always 2+. It's in the main group, so it's always 2+. And then we go ahead and we name the anion. That's the chlorine. This is monatomic, so we change its ending to chloride. Now, it's monatomic. Even though there are 2 of the chlorines, they're each individual ions. Now let's try another one, FeCl2. FeCl2, our cation is iron. Now, iron is a transition metal, and it can have either 2+ or 3+. So we need to include the charge of the iron in the name. Now, how do we determine the charge? Well, we can see that the chlorine is always 1-. So that means if I have 2 chlorines, that means that the iron must be 2+ in order to balance it out. So this would be iron 2 chloride. We need to include the charge to differentiate FeCl2 from FeCl3. FeCl3 is iron 3 chloride. Now, the name here, the number here, gets it from the charge of the cation. In this case, it's Fe2+, and here it's Fe3+. Now let's look at some polyatomic ions. So let's say we have NH4 2O. Well, NH4 2 or NH4 plus, that is ammonium. So we start off by writing down the cation, ammonium. If it's polyatomic cation, you do not have to put the charge in brackets because ammonium is always 1+. And then we go ahead and we name the anion. This would be ammonium oxide. Oxygen is monatomic, so we change its ending. Let's look at one where the anion is polyatomic. So here we have NH4, 2, SO4. So we have ammonium, and then we say sulfate. We do not change the ending from sulfate to sulfide because ammonium sulfide would be with an S. This would be sulfide. So that is how we name ionic compounds.